welcome to Sekho. In this video we are going to analyze the instantaneous velocity numerically. So we have drawn this picture in the previous video, and we have said that the instantaneous velocity at any point on the position time graph is the slope of the tangent at that point. So in this video we are going to explain instantaneous velocity numerically. Let us say that this plot, if you take any point, you have a time corresponding to it and a position corresponding to it. So each point on the position time graph is associated with a time and a position. So what a time and a position, each point has a time and position. So let us say that this time and position has a relation, and this relation can be written like this: x equal to 0.08 t cube. So if you put any value of t, you will get a corresponding x, then you will get a set of x and t, then if you plot them, you will get this graph. Okay, so this is the equation: x is equal to 0.08 into t cube. Okay, now we want to find instantaneous velocity around 4 seconds. We want to find instantaneous velocity around 4 seconds. So what we do is we take delta t is 2 seconds. That means 1 second before 4 seconds and 1 second after 4 seconds. That means t1 is 3 seconds and t2 is 5 seconds. So what we are doing is basically we are taking t1 equal to 4 plus delta 4 minus, we are taking t1 is equal to 4 minus delta t by 2, and t2 is 4 plus delta t by 2. So at first we are starting with delta t equal to 2 seconds. Slowly we will reduce this delta t for getting the instantaneous velocity. So we are finding average velocity taking delta t equal to 2. So when we are taking delta t equal to 2, that means here we have to put 2 by 2 is 1, 4 minus 1 is 3. So we are taking t1 as 3 and t2 as 5, because we have to add 1. And if we put t1 here, that means 3 here, we will get x, and we say that it is x1 and its value is this much. If we put t2, that means 5, we will get this much. Then if we subtract these two, that means x2 minus x1, we get delta x equal to this. Now we have delta x and we have delta t. So if we divide this by this, we get this. That means delta x by delta t is this much. Okay, then we take delta t as 1, so it's half. We will do 4 minus 1 by 2, that means 0.5. so we have 3.5 and 4.5. so 0.5 before 4 and 0.5 after 4. And if we put this on this equation, we get x1. If we put this in this equation, we get x2, and we subtract these two, x2 minus x1, then we get this. So we have delta x and delta t. If we do delta x by delta t, we get this. Similarly, we are doing this. You can use a calculator and you can check by yourself. We are reducing delta t slowly, and we see here an interesting fact that delta x by delta t is 3.8 3.845, then 3.8402, then 3.8400. Actually here in the calculation they have ignored more digits after this 4. Okay, so that's why it is coming 3.84, but it will be 3.8400, then some more digits, but approximately it is approaching. You can see that it is approaching 3.84, isn't it? It was 3.842, but it is 3.8400 and then some digit. So as you are decreasing delta t, you are seeing that the average velocity is going closer to 3.84 meter per second. So you can infer from this that it will, if we make this smaller and smaller and smaller and smaller and infinitesimally small, very very small, it will reach to 3.84. so the limiting value here is 3.84. so we can say that instantaneous velocity, as delta t is very small, it is like just 4, just infinitesimally small, just delta t is so small that it is not crossing 4 in this direction and this direction also. It is almost 4, it is like 4. So if you reduce delta t, so that's why it becomes instantaneous velocity. So finally instantaneous velocity is 3.84. you can do it by yourself at least once in your life. You just do it. You have lots of time in your hand. If you have sufficient time, you should do this. Okay, so this is how we can understand that it approaches to the instantaneous velocity approaches to a certain instantaneous velocity is a certain velocity, but as you reduce delta t, the average velocity approaches to a certain velocity, and we can say that that velocity is that value is the instantaneous velocity. Okay, so this is what for this video. In the next video we'll discuss how we can handle these things, problem of instantaneous velocity by just using calculus. It will be much easier, but for understanding what it means, we have to know what what it means graphically and what it means numerically. So we understood graphical representation of instantaneous velocity as well as numerical representation of instantaneous velocity. Hope you have understood it and you enjoyed it. If you like this video, hit the like button and also subscribe this channel, because this channel is new channel. And if you hit the like button and subscribe this channel, then YouTube algorithm thinks that these videos are important, so they will show this video to more people, and it will reach to those people who really need these videos. So thank you for watching. I'll see you soon in the next video.